So this video is on the cosine rule. Now before I start, I just want to go over the trigonometric terms sin, cos and tan. So here's a right angle triangle in order to demonstrate this. It's a right angle triangle because this angle here, one of the angles in the triangle, is 90 degrees. Now this angle here, we're going to call theta, and we'll give it this symbol here which represents theta. Now I know a lot of people don't actually like the symbol theta. All it is just x that's used for angles instead. It's an unknown algebraic term, but we use theta instead of x. That's all it is. Now this side over here is the opposite. It's called the opposite because it's opposite the angle theta over here, and we give it the letter O, where O is just equal to the opposite. Now this side here is the hypotenuse. The hypotenuse is always the longest side, and it's also always opposite the right angle, but a lot of people realise it by just always being the longest side. And we're going to label it H, where H is the hypotenuse. And then finally, the last remaining side we call the adjacent. It is just always whatever side is left over from O and H, and we give it the letter A, where A is the adjacent. Okay, so sine theta or sin theta, you can call it, is completely fine. Now some people put brackets around the theta. You don't need to, you only really need to put brackets around it if it's an expression of multiple terms, but as it's just one term, you can just say that it's sin theta. Sin theta is equal to the length of the opposite over the length of the hypotenuse, and using the signs, this means that sine theta is equal to the length of the opposite O over the length of the hypotenuse H. Cosine theta or cos theta, you can call it, is equal to the length of the adjacent over the length of the hypotenuse, which is A over H. And then finally tangent theta or tan theta is equal to the length of the opposite over the length of the adjacent, which is O over A. And we can write them all like this. Now the way I remember this, and I think the way most people remember this, is by if you take the first letters of all the trigonometric terms and you take these letters here, you create SOHCAHTOA, where the SO is the SOH for the sin, and then the Ka is the CAH for the cos, and then the TOA is the T and then OA for the tan. And by reciting this, I can always remember how they work, and everyone uses it really, and I still use it now for trig, and I've been doing it for a long time. And then using SOHCAHTOA and using these rules, we can find unknown sides in right-angled triangles, but this can only be used in right-angled triangles. So for example, let's say that we had a right angle triangle with one of the angles being 30 degrees and one of the sides being 5, and we need to find this side here, which is equal to x, and we need to find x. Now a lot of the time what I do is I label the triangle with O, A and H in order to find the opposite hypotenuse and adjacent. So this side here is opposite the angle here that we know, so this is going to be the opposite, and we're going to label it O. This is going to be H, as it's the longest side quite clearly, and then this side down here is therefore going to be A, as it's the one left over. Now we don't need A here because we don't need to find it and we don't know anything about it. We have O and we have H. We need to find O and we have H. Therefore we need to use the trigonometric ratio that has the opposite and the hypotenuse. And if you use SOHCAHTOA, you can see that it's going to be the sin one here, because that has the O and that has the H. And we know that sin theta, using SOHCAHTOA, sin theta is equal to O over H. You kind of go around like that in order to use SOHCAHTOA. And then what you do is just sub the values in. So it's going to be sin, and then theta in this instance is 30, is equal to O, which in this instance we don't know is x, over H, which is over here, so this is 5. And then all we do is just rearrange in order to find x, times both sides by 5 to get 5 sin 30 is equal to x. So therefore x, if you put it into a calculator. Now, by the way, from GCSE you might need to remember, might remember that you needed to know the 0, 30, 45, 60 and 90 degrees sin, cos and tan values by heart. Now, because all of the exams at A level all calculator allowed, you don't really need to remember these anymore. If you do remember them, it's a bit quicker than putting it into a calculator, but it really doesn't matter anymore. So if you put this into a calculator, 5 sin 30 is equal to 5 over 2. So x is equal to 5 over 2. So here's another example. So the first thing that we should always do is the labelling. So this is going to be O, as it's opposite the angle. This is the longest side, so it's H, and therefore this is going to be the other side, so it's A. We need to find A, and we know O, so therefore we don't know anything about H, we're just going to ignore it. So it's O and A, so that's the TOA part, which is tan. Remember, it's tan theta is equal to O over A, and then we just sub in the values. So tan and theta in this instance is 49. It's equal to O, which is 3 over 2, over A, which is x. Now this looks quite horrible to start off with because we have a fraction in a fraction and it's in the numerator. The way that you just do it straight away is whatever the numerator is here, you just put it to the numerator here, but I always kind of forget that. So what I just do is I'm just going to times everything by x to get x tan 49 is equal to 3 over 2, and then just divide everything by tan 49 to get x is equal to 3 over 2 divided by tan 49. And if you put that into a calculator, that is equal to 1.304. So x is equal to 1.304. Let's do one more. In this case we have two sides that we know 6 and 5, and this time we actually need to find the angle. The process is the exact same. This is the angle theta, so therefore this is going to be the opposite. This is the longest side here, it looks like, so this is going to be H and this is going to be A. We know nothing about O in this instance, we don't need to find it and we don't know its value, so we're going to ignore it. So then it's A and H, so therefore we're going to find the trigonometric ratio that has A and H, and if you look at that, that's going to be cos in SOHCAHTOA, cos theta is equal to A over H. Now we're writing out as cos. Now obviously we don't know theta, so we're just going to keep it as cos theta is equal to A, which in this instance is 5, and then H, which in this instance is 6. And in order to find theta, we need to do the inverse trigonometric ratio. So we do theta is equal to cos of -1 of 5 over 6. If you don't know how to get that into your calculator, basically you just press shift and then you press the sin, cos or tan that you need. So in this instance we're going to press cos in order to get the cos inverse. So it's going to be cos inverse of 5 over 6, and if you put that into your calculator, that is equal to 33.6. So therefore theta is equal to 33.6. Now, really quick, the spec specifically mentions that you need to know the use of x and y coordinates on a unit circle in order to give cosine and sine values. Now, for some reason, they word this in a really complicated way, and to be honest, I don't think you really need to know about it, but as it's on the spec, I just want to go through it really quick. If we have a unit circle on an axis like this, a unit circle, if you don't know, a unit circle is just a circle with a radius of 1 and a centre at the origin 0, 0. If you think back to the circles chapter, it will actually just have an equation of x squared plus y squared is equal to 1, because it has a radius of 1 and a centre at 0, 0. Now, if we have a unit circle and we take any point that lies on the circumference of that unit circle, so let's just take this point here, and let's call it x, y. If we draw this line in here, attaching the centre and this point, and we make a triangle by connecting this to the x-axis of a straight vertical line, and then connecting these two lines of a horizontal line like this. This is a right angled triangle because we've got a horizontal line and a vertical line connected together. This side here is going to have a length of 1, because if you think about it, this is the radius, this is connecting the centre and a point on the circumference. That's the definition of the radius, and we know it's a unit circle, so it's a radius of 1. And this side here is actually going to have a length of y, because again, if you think about it, this here is 0 and this here is y, and therefore the length of this side is just kind of between that, so therefore the length of the side is going to be y, and by the same logic the length of this side is going to be x. And let's call this angle here theta. We don't know what it is, let's call it theta here. Now, if we take sine of theta, we take sine of theta here. Quickly, let's assign the opposite, hypotenuse, and adjacent. So this is opposite theta, so this is going to be the opposite. This is the longest side here, so this is going to be the hypotenuse. This is going to be the adjacent here. If we take sine of theta, remember that sine of theta using SOHCAHTOA is sine theta is equal to the opposite over the hypotenuse. Therefore, it's going to be sine theta, it's still theta, as we don't know what theta is equal to the opposite, which here is y, over the hypotenuse, which here is 1. And therefore it's y over 1, so therefore it's just going to be y. So therefore, sine or sin of theta is going to be equal to y. And by the same logic, if we do the cosine, so remember that cos of theta or cosine theta is equal to, using SOHCAHTOA, a over h in this part here. Or we can sub in values to do cosine or cos theta, you can use either term, is equal to a, which is x, over the hypotenuse, which is 1, which again we can just simplify to x. So therefore cosine of theta is equal to x, and we can use these two terms here in order to find exact values of sine and cos theta values. So for example, let's say the point was half and root 3 over 2. This point lies on the unit circle. If you want to, you can sub it into the equation in order to prove it, but it lies on the unit circle, and let's just say it's somewhere about here, half root 3 over 2. If we draw in the triangle again, remember that it's a right angle triangle. Well, this triangle, if you draw it out and use a protractor, or if you use some sort of computer program, you will always find that this angle here, no matter what you do, is always going to be 60 degrees. There's kind of no kind of mathematical justification I can give for that. That's just going to happen given the kind of things that we've made this triangle. It's always going to be 60 degrees, this angle. And let's say that we want to find the value of sin or sine of 60. Well, we can easily find this because we figured out from before that sine theta is equal to y, and now we know theta and y, we can say that sine 60 is equal to y, which in this instance is root 3 over 2. And we can do the exact same for cos 60 is going to be equal to x, and in this instance x is a half. And this is actually how we can calculate exact values of sin and cos values. Now, to be honest, I don't really think you need to know this. It's kind of annoying. I spent a fair chunk of this video talking about it. The only reason I'm mentioning it is because, as I showed, they specifically mention it on the spec. So it's technically possible they could ask it, but honestly, I wouldn't worry about it too much. I don't really see how they could word it into a question at all. So finally, we can move on to the main part of this video. Let's start talking about the cosine rule. So here's the triangle ABC with the vertices labelled A, B and C. Now let's call the sides opposite to these vertices the lowercase of that letter. So this side here is opposite the vertex A, so we're going to call this lowercase a. This is opposite the vertex B, so this is going to be lowercase b, and this is going to be lowercase c. Let's call the actual angles A, B and C depending on what vertex they're at. So this angle here is at vertex A, so it's going to be angle A, big A. This is going to be angle B, capital B, and this is going to be angle C. Now, for the case of the cosine rule, we only need one angle. So for simplicity, I'm going to ignore B and C, and we're just going to focus on A. The cosine rule is that the length of A here, the length of A squared, is equal to B squared plus C squared minus 2BC cosine of A, this angle here. This isn't given to you in the formula booklet, so you actually have to memorize it. Now, the order of B and C, if you think about it, doesn't actually matter. You can flip these around. It's not too important. The important thing is that this angle here has to be the uppercase of this here, aka they have to be the opposite angles here in order for this to work. That is the important thing. Now with the cosine rule, what's nice about it is that if we know 3 of these things, so if we know 3 of A, B, C and capital A, the angle, we can therefore figure out the other one. So let's say we know BC and the angle A, therefore we can figure out A from that. And the other nice thing about the cosine rule is we can use it for any triangle, not just right angle triangles. So you can use the cosine rule in 2 instances, and you should remember these 2 separate instances. The first one is when you need a side and you're given 2 sides and the angle between these 2 sides. So in this example we have the triangle ABC with the sides of 5 and 6, and we know the angle in between of 60 degrees, and we need to find the other side here, x. So we can use the cosine rule here. Let's just use the label that we've already got, A, B and C. So we can use the cosine rule. A squared is equal to B squared plus C squared minus 2BC cosine A. Now what we can do is, let's just do the labeling code. Let's just use the sides that we've already got. So this is opposite A, so this is going to be little a, this is opposite B, so this is going to be little b, and this is opposite C, so this is going to be little c. And then we just sub in the values, with this being angle A, which is already the form of the cosine rule that we've already got. So it's going to be A squared, which is x, so it's going to be x squared is equal to B squared, which is 6, so 6 squared, plus C squared, which is 5, so it's going to be plus 5 squared, minus 2, 6, 5, and then cosine A, which is 60, it's going to be cosine of 60. And if you put this all into a calculator, you get out the value of 31. So therefore x squared is equal to 31. So therefore in order to find x, we just need to take the square root. So therefore x is going to be equal to root 31. Obviously it's going to be the positive one. So this is the answer here. X is equal to root 31. And this is one of the times in your mind you should be thinking cosine rule. If you need to find a side and you're given 2 sides and the angle in between them, use cosine rule.